scatter diagrams, more commonly called scatter plots. Our objective, we want to draw and interpret scatter plots. Well, let's begin with what is a scatter plot. A scatter plot is a graph that shows the relationship, if there is one, between two quantitative, which means numerical, variables measured on the same individual. As an example, perhaps we're going to measure an individual's height and an individual's weight. We would then use those two variables and plot that on a scatter plot. Each individual in the data set is represented by a point on the scatter plot. The independent variable is called the explanatory variable, the x variable, and it is plotted on the horizontal axis. The explanatory variable is the one we're using to make predictions. By the way, sometimes it's called the predictor variable. The y variable, the dependent variable, is called the response variable, and the y variable or response variable is plotted on the vertical axis. The response variable is the variable we want to predict or to explain. All right, here are some examples. I just copied these out of the book. Let me get my paper straightened out. Some examples of scatter plots. The top two are linear. We want to note that. Okay, your explanatory variable is on the x-axis, the horizontal axis. Your response variable is on the y-axis, the vertical axis. And you can see we have here a linear relationship. As the explanatory variable increases, the response variable increases. There appears to be a linear relationship, and it's positive. If you want to make a note of that, this is a positive linear relation. As the explanatory variable increases, the response variable increases. That's a positive linear relationship. Here's another linear relationship. It is a negative linear relationship. A negative, it's going down from left to right, it's going down. As the explanatory variable increases, the response variable is decreasing. As we increase on the x-axis, we're getting points that are decreasing on the y-axis. Here are three examples of non-linear scatter plots. Okay, this one looks like it might have, for those who have a background, a quadratic or a degree 2 relationship. Here's one that has a degree 3 relationship, a cubic relationship. Again, if you've got a math background, you recall. And here's an example of no relationship at all. We don't see any pattern here with a line or a curve. Okay, our focus for this unit is we're focusing on the two linear graphs. So we're focusing here and here. We're not concerning ourselves with nonlinear graphs, and we'll just have to recognize that it's not going to happen. There's no relationship. We're focused here and here. Two variables have a positive linear relationship here. As the value of the explanatory variable increases, as this value increases, the value of the response variable increases. The response variable also increases. Note the line, if we were to draw a line of best fit, okay, through those points, goes up from left to right. That's positive. Two variables have a negative linear relationship if, as the value of the explanatory variable increases, so we're going from 0 up, the value of the response variable decreases. As we go increase here, we're decreasing here. That is a negative relationship. The line, if we draw a line of best fit, goes down from left to right. All right, let's just make a note how StatCrunch does this for us, because we're going to let technology draw these graphs for us. We create a scatter plot in StatCrunch by going to Graph, Scatter Plot, and let's do that quickly. So I've opened up StatCrunch, and I've gone, let me get it there. Let me let you catch up here. Let myself catch up. I've opened up StatCrunch and I've gone to data set from your textbook 4_1_27, problem 27 in section 4.1. And this has to do with commute time. I can probably, commute time is the X explanatory variable. And I think this is this Y variable, which says I can't get it to shift. This variable here is satisfaction, okay? Job satisfaction, I believe, is what it is, okay? So I have commute time as the X variable, as the explanatory variable, and I have job satisfaction, I believe that's what this is, as the response variable, okay? And you'll see I only have 7 points here. It stops at row 7. So let's make a scatter plot. We'll go to graph. Graph is here. And we'll go to scatter plot, which is right down here. And you need to let it know which is the X variable, which is the explanatory variable, and which is the response variable, the Y variable. Well, the X variable is the commute time in minutes. The Y variable, it's about a well-being. So yes, it is satisfaction. It's kind of well-being. The Y variable is the Gallup Well-Being Index score. Those are two quantitative, measurements. And then we just have to simply come down to here and create it. And over here is my compute button. And there is the scatter plot. Notice down here at the bottom, it has the label. The commute time is in minutes. And up here we have the well-being index composite score, how you feel. And you can see that if we were to draw a line here, it has a negative linear association, a negative relationship. As your commute time is increasing, your well-being score is decreasing. And that makes sense. No one likes their commute time to be long. And so as your commute time, in this case, over 100 minutes in this dot right here, in this data point, that person is not very happy. The commute time is really long. Whereas up here, the commute time is quite short, and that results in the person having a high well-being index score. But there's how we create a scatter plot in StatCrunch.